Welcome to the Agile Engineering Deep Dive Podcast. I'm Alessandro Guida, and today we're exploring a topic that is reshaping how software is built everywhere: vibe coding and the rise of AI-generated development. For the first time, developers can describe what they want in natural language and watch entire modules, tests, and scaffolds appear in seconds. It's impressive. But it also raises a deeper question. What happens to architecture, quality, and engineering rigor when the code comes first and the design comes later? Or not at all? In this episode, we take a clear, honest look at what vibe coding can accelerate, what it can break, and why the biggest risk is not the technology, but adopting it without the maturity and guardrails that real engineering demands. We'll talk about how the programmer's thought process changes, where human judgment becomes even more important, and how organizations can integrate AI responsibly without creating accidental complexity. Let's dive in.
Welcome back to The Deep Dive. If you're building anything today, you know the rhythm has it's completely changed.
Yeah.
It's no longer about this sort of linear progress. It's about embracing rapid, often, exponential change.
Mm.
And right now, there's one term that you just hear everywhere in software engineering.
Oh, yeah. Vibe coding.
Vibe coding, exactly. And, what are we even talking about here? This isn't just an AI suggesting the next line of code.
No, it's not autocomplete.
Not at all. Vibe coding, in its purest form, is about giving in completely to the intent.
Yeah.
You describe the outcome you want in just plain English.
You give it the vibe.
You give it the vibe, and the AI generates the entire application. I mean, the logic, the config, the full multi-file scaffolding, even the UI and tests, it sounds like magic.
It does. But what's fascinating is that every veteran engineer listening to this right now has this powerful sense of deja vu.
You've been here before.
We have seen this movie before so many times. It's always marketed as the next revolution. I mean, think about 4GLs way back when, or the whole UML to code idea.
Oh, the dream of drawing a perfect diagram and having the app just pop out.
Exactly. Or low-code, no-code platforms. They've been trying to solve this for years.
But to be fair, some of those movements delivered real value, right? I mean, microservices completely changed how we think about deployment and scale.
Oh, absolutely. And that's the key point. The critical lesson from all those attempts is that while they raised the level of abstraction and gave us immense leverage, none of them delivered magic. None of them just erased the need for disciplined engineering thought. They abstracted the syntax, maybe the boilerplate.
But not the hard stuff.
But not the architectural choices. They couldn't abstract away the complexity. They all sort of failed on the assumption that the hard part of engineering was typing.
When really, the hard part is thinking.
That's it. And that brings us to the central question for this deep dive. Is vibe coding different? Is it a genuine breakthrough, or is it just the next incredibly powerful tool that actually demands more rigorous engineering oversight?
Okay, so that's our mission. We need to look past the hype. We'll assess the promise, run a serious engineering reality check with a real-world example, and then figure out a sustainable hybrid workflow.
Right. How do we get the speed without just creating a mess?
Exactly. How do we keep our systems running?
The term itself, vibe coding, it perfectly captures that feeling of abstraction.
Mm-hmm.
Andrej Karpathy really popularized it back in 2025.
Right, he had that quote.
Yeah, his description of the mindset was, you fully give in to the vibes, embrace exponentials, and forget that the code even exists.
And that mental shift that's where it gets really interesting for me. Because historically, every time we tried to raise the abstraction level,
Like with SQL.
right, declarative SQL or visual tools like Simulink, the engineer was still, tethered to the underlying structure. You were still breaking the problem down step by step.
Analytically,
Yeah.
That's the key word. And the difference now is just the sheer breadth of what these LLMs can do. They don't just fill in a small gap.
No.
They can infer these complex relationships across dozens of files. They can handle your Docker config, generate multi-component apps as a whole other level.
So we're moving away from having to understand the machine in the same way.
We are, but that comes with a pretty big trade-off.
Well, it challenges everything we learned from books like, The Pragmatic Programmer. Traditional coding was all about that analytical construction. You built the mental map of the system by building it. You had to reason through every single edge case.
For decades, the motto was basically, I build it. Simple as that. But this vibe coding shift, It changes that entire cognitive relationship.
How so?
Your mindset moves from that analytical construction to, to curation.
Curation.
You're not primarily building anymore. You're defining the intent declaratively, and then your main job becomes validating, correcting, and strengthening what was generated.
So the AI does all the mechanical work, the scaffolding, the boilerplate.
All the tedious stuff.
And the human's role becomes the specialized one. You are the primary validator, the architectural guardian.
That's it. The motto is, now I define it, and we build it together. And for experienced engineers, this offers incredible leverage. You can prototype something in minutes.
Something that used to take days.
Absolutely. But, and this is a huge but, the whole model falls apart if the human doesn't maintain that critical oversight. Because the AI, it's fast, but it is completely intellectually indifferent to engineering quality.
Okay, so to really understand that trade-off, that risk you take when you skip the analytical construction part, we have to look at a concrete example. Okay. The source material had a great one.
Yeah, a really simple experiment. Generating a little utility app from just a single user story.
And the story was super straightforward. It was, as a PC user, when I copy a very long URL, I want it to be automatically replaced with a short one.
A genuinely useful little app that would live in your system tray. Simple.
And the output was, it was dazzling. The AI just spat out a complete Python application. It handled system monitoring. It detected the URL.
It integrated with the TinyURL API to shorten it.
Replaced the clipboard content, added a system tray icon with a toggle. It even generated test cases.
All from 2 sentences of English. That is the magic.
Yeah.
Right? That's the promise.
It is. But then came the reality check.
Then came the code review.
Yeah.
Performed by this experienced engineer, Andreas, and he exposed that massive gap between a functional prototype and production-ready code.
And the flaws weren't just like stylistic things, they were fundamental architectural mistakes.
Oh, absolutely. The first one was just a classic. Instead of using the proper event-driven Windows APIs,
which are designed to tell you when the clipboard changes.
Right. The AI chose the easiest path. It just created an infinite loop to constantly check the clipboard. Polling.
So what's the big deal with polling? It works.
Well, that choice has real consequences. It's not just a minor inefficiency. You're forcing the app to wake up and check the system every few milliseconds, constantly.
On a laptop, that's
battery drain, that's CPU load, it's potential instability, all from an app that's supposed to be sitting silently in the background.
He also found some security issues with tracking parameters in the URLs and resource waste, like regenerating the tray icon over and over again in the loop.
The code worked, but it was incredibly selfish with system resources.
And this leads to 2 lessons that are you can't argue with them. First, the path from prompt to code.
Yeah.
It just skips design and architecture entirely.
Completely. The AI doesn't think about long-term stability or performance or efficiency. It just finds the shortest path to making the words in the prompt happen.
Yeah.
Performance and security become,
they're accidental.
They're accidental outcomes, exactly.
Yeah.
And the second lesson.
Code review.
Code review by an experienced human remains absolutely non-negotiable. Vibe coding is a fantastic tool for prototyping, but only an engineer who actually understands the OS, the security model, the cost of resources. Only that person can turn the prototype into something sustainable.
You still need the human who worries about the machine.
You absolutely do.
So if the AI has mastered acceleration, then we have to focus on what it can't do, the irreplaceable parts of human engineering judgment.
Right.
It's not about can we code it anymore. It's about should we. And let's start with the biggest one, system thinking.
System-level thinking is it's beyond the AI's scope. It's about designing coherent systems that line up with, complex business goals, operational realities. An LLM can write a great microservice.
Sure.
But you can't decide if that service should talk to the old legacy database or the new cloud stream. It doesn't have the context of the 3-year roadmap or the tribal knowledge in the organization.
And that lack of high-level context that directly creates a cognitive risk. Let's call it the loss of system overview.
That's a good way to put it.
Because the engineer didn't build the system brick by brick, they don't have that mental map. They can't really predict how it will behave across different modules, especially when things go wrong.
And a related skill that AI just fundamentally lacks is a professional sense of quality.
You mean like elegance?
Elegance, maintainability, clarity, all that stuff that comes from true craft. It's the difference between code that works and code that's beautiful and easy to change later.
And if you bypass that quality check, you get the second cognitive risk. Accidental complexity accumulates silently.
Oh, this is the core of technical debt. This is how it happens. The AI might use one dependency pattern in module A and a totally different one in module B.
It mixes and matches.
Exactly. It might mix old synchronous I/O with modern async patterns. And that unintentional mess just emerges silently, and it makes future maintenance a nightmare.
Okay, what else can't be replaced?
Judgment and prioritization. Engineering is, at its heart, the art of compromise. Making those trade-offs, speed now versus scale later, more features versus more security, that's a uniquely human thing tied to risk and business consequences.
And if the human doesn't make that judgment call, you fall into a trap. The illusion of completeness. The generated code, it looks so polished, it seems finished. But that polish hides all the missing error paths, the security gaps, the performance bottlenecks.
Making them much harder to spot than if you'd written the first messy draft yourself.
Right. Then there's the non-technical stuff, ethics, regulations.
All of it. The AI generates code based on patterns it's seen. It has no concept of harm or liability or the massive fine you'll get for a regulatory breach. That is all on the human engineer.
And finally, the most painful one. The long-term ownership mindset.
The tenure problem.
The tenure problem. The AI generates the code once. A human has to maintain it for the next decade. And if that engineer never actually formed the underlying mental model of how it works,
you get weak debugging ability. You're just guessing. You're not tracing a root cause. You're just poking at it, hoping something works.
And if you keep regenerating parts of it, you get architectural drift.
Total inconsistency. Each prompt might create a slightly different pattern, and the whole code base becomes this unmanageable, untestable thing. It's simple, really.
AI accelerates creation.
But only humans ensure coherence. So, okay, if the risks are that big, what do we do? How do we move forward? The goal has to be about keeping the speed of AI, but adding back that engineering rigor.
There has to be a guiding principle.
And there is. And it's beautifully simple. AI accelerates. Engineering stabilizes.
I like that. So we have to move beyond just trusting the output. We need a real structured workflow that puts human expertise back in, both before and after the generation.
Exactly. And step one is preparation. The human has to define the boundaries. You factor the system into small, manageable units. You give the AI structured problems to solve, not an entire monolith to invent.
Okay, and step two is the prompt. And this is where the big innovation is. You write your user story, but you add explicit constraints.
This is where you inject the architectural intelligence.
And you have to be specific with those constraints.
Oh, very specific. Things like must adhere to the MVC pattern, or must use our established internal logging library, or even must target a memory ceiling of 150 megabytes.
You're tying the AI's hands functionally to enforce all the non-functional requirements: performance, security, maintenance.
That's it. Then step three is generation. The AI does its thing, produces the code skeleton following your rules. That's the speed boost.
And then the most important part, step four, the rigor phase.
The human intervention. This is where you treat the output like it's a foreign code base from a new junior dev. You run it, you test it.
You do a deep code review.
A comprehensive one. The engineer adds proper structure, improves performance, puts in robust error handling, and makes sure the tests are actually meaningful, not just checking for happy paths.
And the outcome of that whole discipline process is code that's actually production ready, reliable, maintainable, testable.
And we're seeing platforms pop up all over, designed around this workflow, from IDE tools like VS Code and Copilot,
to full app builders like Base44 or Lovable, and even enterprise things like Cloudflare's Vibe SDK.
And they're all fantastic accelerators. They let engineers spend less time typing and more time thinking and validating. But they all work under the same exact limitation.
They're a force multiplier, not a replacement.
Not a replacement for architecture, design, or QA. Never.
And that really highlights the biggest organizational risk we have right now. The danger isn't the AI.
No.
It's organizations that adopt vibe coding blindly. They rush to get the acceleration, but they don't put in the guardrails or have the engineering maturity. If you skip that human rigor phase, you are not saving time.
You are generating immense technical debt at a terrifyingly fast pace. You're building fragile, unstructured systems that will be impossible to maintain. Hashtag outro.
So the core conclusion here seems pretty clear. Vibe coding is a profound shift in how we build software, but its utility depends completely on the discipline we bring to it.
That's right. It is the ultimate accelerator for solving well-defined problems. Used carelessly, it becomes a high-speed complexity generator.
The future belongs to the teams that can master the art of curation, not just generation.
Exactly. They have to combine that AI speed with an uncompromising engineering discipline. The human has to remain the source of architectural coherence.
Now, if you want to go deeper on this mindset shift and how it affects the craft of engineering, the source material has 3 essential book recommendations.
Yeah, 3 great ones. First, The Pragmatic Programmer. It's foundational for craftsmanship, for effective habits. Yeah. It helps you define the kind of quality you need to be looking for in the generated code.
Okay. And second, Thinking Fast and Slow.
A brilliant one for this topic. Vibe coding pushes us towards that fast, intuitive thinking system 1 by offloading the slow, analytical reasoning to the machine. Understanding that distinction is critical.
So you know when to stop and engage that deep, slow, analytical rigor for architecture and debugging.
Precisely. And finally, Code by Charles Petzold.
A classic.
It strengthens your fundamental mental model of the machine itself. When you're not seeing the code being written line by line anymore, you need an even stronger foundational understanding of the hardware, the OS, of what software fundamentally is.
So you can provide effective oversight. We've covered the promise, the pitfalls, and the path forward for this new era.
So here's a provocative thought for you to take away. Since AI is going to handle more and more of the boilerplate and the scaffolding, and we've established those 5 irreplaceable human skills, what new non-coding skills beyond those 5 things like organizational communication, building consensus, complex stakeholder alignment, what skills like that will become the most critical differentiators for human software engineers in the next 5 years?
That is a great question to ponder as our jobs fundamentally change. Thank you for joining us for the deep dive.
Thank you for listening to the Agile Engineering Deep Dive podcast. If today's episode gave you new insight into working across teams or highlighted the role of discipline in achieving real agility, feel free to share it with your colleagues or your network. You can find the full written article along with previous episodes in the Agile Software Engineering newsletter on LinkedIn. And if you have thoughts, questions, or examples from your own organization, I'd be happy to hear from you. Your experiences help shape what we explore next. Thanks again for tuning in, and I'll see you in the next episode.